Hey, what's up guys? This is Still Rain and welcome back to my channel. And before we get started, I'd like to wish you all a Merry Christmas coming up here in a few days. And what we're going to be looking at today is the power output of the TBS Unify Pro high voltage video transmitter. Now, going back to my last video transmitter shootout video, a lot of guys were complaining about some of the testing parameters and things like that. And I'd like to say, guys, this isn't scientific testing. This is just bench testing with the Immersion RC RF power meter. It might not be the most accurate meter or way to measure these things in the world, but it's going to give us a good ballpark. And I had a lot of guys complaining, and rightfully so, on the last video. I didn't quite explain the full testing procedures. So I'll go ahead and kind of clarify some of that here. Anything else you want to know is going to be in the video's description, the way I go about my testing. So last time I used a TBS Unify Race 200 milliwatt video transmitter as a baseline, and a lot of guys said, okay, well, that's not the best for a baseline, but that wasn't really the point. The point is just to see what it put out according to manufacturer's claimed output ratings and what the meter read, and it was spot on. But a lot of guys said, maybe that's not accurate or the meter's not accurate. So I went ahead and got another TBS, this one here, that goes up to 800 milliwatts, just got it in. And like I said, a lot of guys, they also said that I didn't have any airflow going over the video transmitters, that they were powered on too long. In between testing each video transmitter, the rig was powered off, and the video transmitters that were powered on at 25 milliwatts, which is hardly anything, were allowed to cool back down to ambient temperature before I tested them. So, they all had their fair shot to either, perform to their manufacturer's stated outputs or fall flat on their face. Another complaint also was that I only tested on the center frequency of 5800 megahertz, or exactly 5.8 gigahertz, and that usually the lower you go in the band and channel, like Raceband 1 is pretty low, the more powerful the video transmitter will get. So in this video, I'm going to be testing this starting off on 5800 megahertz, and I'm also going to be testing Raceband 1 and Raceband 8. So, there's going to be a wide spectrum of everything possible from high to low all the way to the center frequency. So we'll go ahead and get started. And this, like I said before, this is just powered off the main power of this rig here, my long-range rig. And once I plug it in, you guys will go ahead and see exactly how it performs. It is powered by a full-powered 4S battery at 16.8 volts. And I'll sit here and let it warm up for a bit, guys, so you can see exactly how it's performing. As you can see, it's already dropping a little bit. It's powered on 5800 megahertz exactly, and roughly around 30 milliwatts. It's kind of bouncing around a little bit, but not doing too bad. Pretty close to its stated output. It's 25 milliwatts. So what we're going to go ahead and do now is we're going to go ahead and change it to Raceband 1 and Raceband 8. Go ahead and go to Raceband 1, so this should be more powerful once it's set. As you can see there, it's hovering around 35, 36 milliwatts, somewhere around there. So a little bit better overall, performance in that case. So what we're going to go ahead and do now, and that's pretty low in the spectrum. That is 56, 58 megahertz. So pretty low in the Raceband. So what we're going to go ahead and go do now is go to Raceband 8, which is 5917. Go ahead and set it here. And it'll fluctuate just for a second there. And as you can see, it's putting out 24, 25 milliwatts pretty steadily. So I think the accuracy of this meter is pretty good, but what we're going to go ahead and do is also we're going to test the 800 milliwatts feature of this. So right now we're on Raceband 8, and we're going to go ahead and go up in the power. See what it sits at there. As you can see, on Raceband 8, it's sitting a little bit low at 652 milliwatts. And to tell you guys honestly, this VTX is being taxed more than the other ones because it's been powered on this whole time, where the other ones are just powered on for a lot less time. And as you can see, as it heats up even more under 800 milliwatts, it'll drop. So, you know, Raceband 8 isn't the best because it's pretty high, 5917 megahertz. So what we're going to go ahead and do now is go back to Raceband 1 and see where it jumps to from there. As you can see there, Raceband 1 being 5658 megahertz, it's transmitting well over 800 milliwatts. And like I said, this isn't scientific, guys. This is just a bench, but I guarantee you this is all pretty accurate, you know, and within a ballpark of what it's supposed to be doing. So what we're going to go ahead and do now is go back to, once I can get my FPV screen here, going back to where it's supposed to be. See if I can get it to show up here. As you can see, it's dropping a little bit too. It's down to 820 now, but full on 800 milliwatts power output. It's heating up pretty good right now. All right, so what we're going to go ahead and go do now, guys, I'm going to go back to the center frequency of 5800 megahertz, which is Fat Shark channel 4. Go ahead and set that at center frequency right now. As you can see right there, kind of fluctuating between 794 to 820, somewhere around there. Like I said, you know, it's probably getting pretty hot by now. Yeah, I could feel it. It's getting pretty hot by now, but this one's being taxed a lot more than the other ones that you guys have seen in the past in my last VTX shootout. That'll also be down in the video's description. And, you know, like I said, guys, this thing's performing pretty well, and the meter matches up to it pretty well. So there's a lot better ways to test this, you know, with different equipment, but this is all I have at my disposal. And like I said, you know, the last video, a lot of guys said I wasn't testing low enough or high enough bands. I was just testing 5800 megahertz. As you can see, it does make some sort of slight differences in the power output, upwards of like, you know, 150 milliwatts on 800 milliwatt setting. So, but like I said, this thing's performing pretty well considering there's no airflow, you know, powered off the same battery voltage and everything as last time. So with that, guys, I'm going to go ahead and call this video quits. We're also going to be testing a Tramp high voltage video transmitter in the future that goes up to 600 milliwatts, along with a few others that I'll be having coming in. So that's going to be the end of the video, guys. Whoop, I'm going to go ahead and have to unplug it here. That's going to be the end of the video, guys. So if you enjoyed the video, learned anything, please subscribe to my channel. You know, like, subscribe, and share the video. And please leave any questions, comments, or suggestions in the normal place below, and check the video description for any more details on the testing. Thanks, guys. I'll see you next time.